Well, hello guys, here Mr. G with another question for the grade 11 related to stoichiometric. This is a quite important work, and this question is quite interesting because it's a lot of things to do here. The question says 2,24 cubic decimeter of H2S is combined with 6,4 grams of SO2 at STP and a chemical reaction. Okay, and there is the chemical reaction. First question, determine the limiting reagent. And that is what we are going to real fast do here. We're going to find out which one is the limiting reagent. And remember, to get the limiting reagent, the first thing you need to do is to calculate the number of mole of both reactants. In this case, we're having H2S and SO2. So we're going to work on this side for H2S. And on the other side here, on the other stream, we're going to work for SO2. All right. Now, let's see what we have and how can we calculate the number of mole. For the H2S, we have the volume of the gas. It is a gas and is at STP. They're telling you is at STP. All right. So first of all, I'm going to write here that the volume of this gas is going to be equal to 2,24 cubic decimeter. It is given to you and it is at STP. Therefore, the molar volume is equal to 22,4 mole per cubic decimeter. There we go. And then we have to calculate the number of mole. The formula we can use here is number of mole is equal to volume divided by molar volume. Real simple, guys, and it is given to you 2,24 divided by 22,4. The answer is 0,1 mole. There we have the number of mole of the first reactant. Let's do the same with the second reactant. So what we have for the second reactant, we're going back to the question and we read there, they say it's combined with 6,4 grams of SO2. So we are having here now the mass for the second one. The mass is equal to 6,4 grams. All right. And now here, guys, we need the molar mass. So we are going to calculate real fast the molar mass of sulfur dioxide here. Yeah, the molar mass of sulfur is 32 plus 2 times 16. And this one will give you 64 grams per mole. There we go. So now here, the formula we're going to use to calculate the number of mole is number of mole equal to mass divided by molar mass. This is 6,4 divided by 64. And the answer is going to be 0,1 mole. There we go. So in actual fact, we can see that we have same amount of mole of both reactants, but it doesn't matter. We're going to do the ratio. So yes, for the next step, we have to find the ratio here for each of the reactants. As you can see, the ratios are 2 for H2S and 1 for SO2. So we're going to come here and we are going to say ratio. Ratio of reactants. You don't have to write of reactants. So the ratio of H2S to SO2. That is the ratio we are looking for. And it doesn't matter because we have the same amount of mole. However, the ratio, let's go back, is 2:1. 2:1. So we're going to substitute. If we have 0,1 mole of H2S, let's move it there and write mole. How much mole of sulfur dioxide will I need? And this one is solved with a cross product. I said the cross product sometimes is very easy, but sometimes it's tricky. So I recommend you to do it even if it's easy, so you get used to it when it's a difficult one. So this one is 2x equal to 0,1 multiplied by 1. So x is equal to 0.05 moles. So what does it mean? It means you only need 0.05 and you have 0.1. Therefore, we can see that the sulfur dioxide here, this one is the excess reagent. This one is the excess reagent, and therefore the H2S is the limiting reagent. There we go, guys. Here is the answer of the question. Now remember something, because we're going to need this one for the next coming questions. Just now, this is what actually it was used, because there was some extras. Okay, but let's go to the next question. The next question says what mass of sulfur is formed. So they want to know how much of the sulfur here is formed, okay, in grams. That is the question now for this specific question B. So let's solve or answer question B real fast. And this one is really easy, guys. Now for question B, to find out the mass of sulfur is like the theoretical yield. We have to use the limiting reagent. And the limiting reagent is the hydrogen sulfate. So we have to use these two now to calculate the mass. So the first thing we have to do is to find the ratio between those two, because we already have the number of mole. So we're going to ratio of H2S to S, and the ratio here is, and let's move this one a little bit up because it's on the stream there, as well as this one here. I think it's enough space. So here we have the ratio is, if you go to the equation we just mentioned it, that I wanted to show you again, is 2:3. Now this ratio, as you can see, is a little bit more tricky. That's why I said you must always try to learn to do the cross product. The ratio here is 2:3, as you can see. We're now working with this 2:3. All right. So the ratio there is 2:3, and we know that the amount of mole of hydrogen sulfide that was used was 0.1. How much sulfur will be produced if we use that 0.1? Let's write 0.1 mole. And now here, guys, as I say, cross product. Quite simple. Cross product there, and then we have, when you do that, 2x is equal to 3 times 0.1. My advice, do it even if it's very easy. 2x is equal to 0.3, and then x is equal to 0.15 mole of sulfur. This one is mole of sulfur. All right, mole of sulfur. So now with this mole of sulfur, we are going to calculate the mass of sulfur, which is the question. What formula are we going to use? Number of mole is equal to mass divided by molar mass. The number of mole, 0.15. The mass, that is what we are looking for. And the molar mass of sulfur in the periodic table, if I'm looking, I have it in front, it's 32. There we go. So the mass, guys, is going to be 4.8 grams. That is the end of that story. This one, remember, could be the theoretical yield. So let's write it here, because we also need it for later on for another question. This one is the theoretical yield. We're going to need it in another question within the same question here. So I hope you understand. That one is not that bad. Question C, calculate the mass of remaining reactant. Remember I told you we're going to come back to this work here. That is what we are going to do. So we want to know how much sulfur is left, not there, but how much excess reactant is left. So in other words, remember the SO2 was in excess. SO2 was in excess. SO2 is in excess. So we want to know how much SO2 is left over. If we go back here, we know according to this ratio that only 0.05 mole was used during the reaction, was needed. So how much is left? We started with 0.1, as you can see there, but we only needed 0.05. So how much is left? And we are going to solve that one right here. There we go. So now we are going to say we started with the initial mole was calculated and it was 0.1. Okay, look here guys, we starting with that one. That was the amount that you starting with. That was the initial amount you starting with. You calculate the moles of that one. That one is the initial amount of mole. Okay, now at the end you only needed, during this ratio you only needed 0.05 that was used. So how much is left over? Now number of mole that was used is equal to 0.05 mole. How much is left? Number of mole left. How much is that? Well guys, very simple. The number of mole left is going to be equal to 0.1 minus 0.05, and that one will give you 0.05 mole. There we go. So this one is the number of mole that is left, but they don't want the number of mole, they want the mass. So all we have to do, look here, the question say calculate the mass of remaining reactants. So all we have to do now is from here calculate the mass. And how we calculate the mass? With the formula guys. Number of mole is equal to mass divided by molar mass. Remember which one is in excess? We're working with the sulfur dioxide. This one is for sulfur SO2. This one is for the sulfur dioxide. So here we are. This is the formula we're going to use. The number of mole, because it's the amount that is left over, is the 0.05. 0.05 is equal to mass divided by molar mass of sulfur dioxide. We already calculated. It was 64. And then the mass is equal to 3.2 grams was left over. 3.2 grams, remember it's 3.2 grams of SO2. That is what is left over. That is question C. It's not that bad. It's really not that bad. Let's go to question D. Calculate the total volume of gas at STP after the reaction has run to completion. Run to completion means the reaction is finished. Now note the following. The only gas we have here in the product is the water, because the water is in a gas station. They're telling you that one. So this one is gas produced. But be careful, because there is some left over. Some of that one is left over, and we know how much is left over. We did calculate it just now. So the total gas will be the one that is produced plus the one that is leftovers from here. So guys, the same thing. The first thing we're going to do is to calculate the number or the volume of water at STP. That is the first thing we are going to do in this question. So let's go here and we are going to question D. This one is question D. All right, now once more we go back, and it's the same process. Step 1, ratio. We are going to use the ratio of the limiting reagent and the water. So in this case we're using the ratio between H2S and the water here, the ratio between those two. All right, so we call the H2S to H2O. The ratio is, let's make clear it is 2:2. 2 is to 2, right? And 2 is to 2 is the same as saying 1 is to 1. I'm going to write 2 is to 2 or 1 is to 1. So if we have what was the number of mole of hydrogen sulfide that we calculated, it was the first calculation here, it was 0,1. You can see it there. So 0,1 mole will produce also 0,1 mole of water gas. So what is the volume? Number of mole is equal to volume divided by molar volume. If you substitute, you have 0,1 is equal to volume divided by 22,4. Therefore the volume is equal to 2,22 cubic decimeters. That is the volume of the water at the end of the reaction. But remember that is not the only volume, because there is leftovers of the which one was the other one? The sulfur dioxide. So was left over of the sulfur dioxide, which we did calculate the number of mole. Look here, guys. So we are going to calculate now the volume of this amount of mole, which is the leftovers. So I'm going to write here for SO2 excess. For SO2 excess, remember the number of mole was 0,05 mole. That was extra. So all we're going to do is we have to calculate the volume. Number of mole is equal to volume divided by molar volume. When you substitute here is a 0,05 equal to volume divided by 22,4. Volume here is going to be equal to 1,12 cubic decimeter. So what is the total volume left at the end of the reaction? Guys, we have to add those two there, because that is the total volume that you will have at the end. The one that is produced here, that one is the one produced plus the one that is left overs from the reactants. So that is the total volume, which we are going to real fast calculate here. So volume total is equal to volume of the product plus the volume left over. All right, and that one will be equal to 2,22 plus 1,12. Okay, now here if we make a mistake here, this one's supposed to be 4 here. If you fix it, please, it's a 4. Try to do the calculation, guys. I'm doing the calculation, but sometimes I'm not looking carefully. I do all the calculations while I'm doing the question here to 4, and then the answer there is going to be 3,36 cubic decimeter. That is the answer, guys. Okay, so now next question, which is the last question. Calculate the percentage yield of the reaction with 3 grams of sulfur. We're working with sulfur. 3 grams of sulfur is recovered, and that one, guys, here is the actual yield. This amount they're giving you there is the actual yield. Now remember, in one of them, when we calculated here in question B, I told you that answer is the theoretical yield. So this is really simple question. So that one is question E, and guys, percentage yield is equal to actual yield divided by theoretical yield. Times 100, and all the numbers are given to you. Therefore, if you substitute, this one is 3, which is given in the data. We're going back there. It's a 3 there. The theoretical yield is 4,8. So 4,8 here divided by 4,8 times 100, and then guys, the percentage yield is going to be 62.5. So percentage yield is equal to 62.5%, and this one is the end of the question. I hope it helps. It's a very good question because it's a lot of things going on in this question. If it did, please thumb up, subscribe for the channel. I'll see you next time. Mr. G here.